the big packet that you got, it's not really not that bad because we're not going to do every single problem in it, even though, you know, it wouldn't hurt. Okay, the big packet is the notes. So let me stress this again for some of you, because I still have about 3 of you out of the group doing this. Notes can be used on quizzes and tests. So this packet that we're going to work through the different problems on is usable on our next quiz, which is probably, I'm not sure if it's going to be Friday or early next week. We'll see. It'll be small whenever it is. So what we're going to do to kind of go over this is do some stuff with like terms and kind of roll our way into it a little bit. So here's how this goes. All right, combine like terms, distribute when we need to. All right, let's do this. In number 1, what things are alike that I could put together? Okay. So this 8x squared and the 7x squared, I know they all have x's, but these are the only ones that have the same exponent. So if I have 8 and I have 7 more, that gives me 15. But then I can't do anything else with the 8x to the third because there are no other x to the third terms. It's just that one.
Why wouldn't you put that?
Okay, good question. Why wouldn't I just do like 15 minus 8 and then mess with the exponents? Here's how I'll describe that. When we're dealing with the same variable but different exponents, it kind of works like this would. If I had 15y minus 8x, would I call it 7xy? You're like, well, no, because those are x's and those are y's. Well, of course not. Okay, same thing's going on here. If this has a different exponent than this.
I'm talking about the 8 and the 2. Like the 2 and 2.
Oh, those. Okay, let me change the question. If I had, let's see.
I already know you can't put the 3 with it. It's different.
Because it's different, but why wouldn't I change those? Okay, so if I had 8x and 7x, is that 15x squared? It's just 15x, right? Right, and that's what we're going to get to. So for right now, if they're the same, I'll just put them together, but I'm never going to mess with the exponents when I'm adding or subtracting. I'm always going to leave them alone. Yeah, we're always going to leave them alone when we're adding or subtracting. I'm glad we kind of went over that because that'll become important here as we go along. But like Eric said, when now we start to multiply this out, now the exponents start to change. Because x times x, I have 1, 2 for an exponent. So I have 7x squared, or 7x to the second power. If I multiply 2 x's, I end up with x squared. And then 7x times a negative 3, well, 7 times negative 3 is negative 21. And I don't have any x's to multiply together. So it just ends up a minus or a negative 21x. Okay, and that's the rule we'll start talking about here in a minute.
I'm asking another question.
No, that's okay.
Can you put the 7 and the 21 together?
No, the same reason I can't put the 15 and the 8 together here. X squared and x are different. So, yep, so they're not like terms, so I have to keep those separate. Now when I move to the next one, nothing to multiply out. What can I put together though? Okay, these are both x squareds, so I can put together the 10 and the 7, but don't mess with the x squared, okay, only when we're multiplying. And then the y's, be careful. Watch the signs that are in front. Negative 21 and positive 31. What's that going to add up to? A negative 20. Oh, Eric's caught me here. Are these like terms? No. Okay. So here, the minus 21y squared and the plus 31y have to stay the same because these are not like terms. See, I almost pulled a silly mistake there. That'd have been bad. So I can only put things together with like terms that are identical with what they've got. So as we continue to work through some of these, like I said, we'll do a couple more here. Here, you're like, well, 2x squared plus this part, only the 3x and only distributes to what's in the parentheses. Okay, so I'm not going to do anything with that 2x squared at the start. But like we said before, when I'm multiplying, I have x1 and another one is 2. So that's 3x squared. And then 3x times 4, well, 3 times 4 is 12 with my x. So the parentheses, getting them out of the way, is always my number one job.
Can you put the 2x in the 3?
I can, because they're both x squared. I can put those two together. So 2 and 3 is 5x squared. Again, I'm not multiplying, so I'm not going to mess with the exponents at all. And then the 12x is just its own thing, so that's all I can do with that one. So you kind of start to see, you're like, okay, so the only time the exponents are changing is when I'm multiplying. If I'm just adding or subtracting, I'm just looking for terms that are alike. So let's see. Let's throw a twist in here. Let's do 5 and 6, because that's where we get into negatives and stuff. So let's see. The 2 is going to distribute in number 5. Okay, so the x squared, not doing anything. That plus kind of separates it from everything else. 2 times x squared. I guess I'll just stick the 2 in front here. So 2x squared. And then 2 times a positive x is a positive 2x. So, once the parentheses are gone, number one thing every time. Okay, the x squared and the 2x squared can go together. What number's in front of x squared if I don't see one?
1.
1. So if I have one of them, and I add 2 more, now I got 3. And this 2x, so that's the only one of its kind, so it just kind of stays the way it is. All right, let's see. One more. Now let's do 6. Always do the parentheses first. So this other stuff, the 5x and the 3y, they just stay the way they are. What's the rest of my problem going to look like once I distribute? Okay. Yeah, we're still multiplying the negative 2, so it's negative 2y. Okay, that negative 2 goes to every term in there. So once I do my distributing, now what?
Why aren't you putting the
In here, if I wanted to put plus negative 2y, I could, but what I've tended to find is most of the time when we put plus and negative, people want to start adding then instead of doing the negative part. So I just noticed that if it's a negative times a positive, I get a negative. Yep. Because now it's easy to see when I go to combine like terms, if I look at my signs, I have 5x's, but then I'm putting a negative 2 with it, or I have 5 and I'm taking 2 away, which would give me 3 of them. Or with my y's, I have 3 of them, and I take 2 away, which leaves me with 1. Or you could just put plus y. Either one of those would work absolutely peachy. So that gave you a little insight into how this exponent rule stuff is going to work. So here's how this goes. We're going to look at it kind of stretched out, and then we're going to put the rule to it. So if I have x squared times x to the third, okay, here's what that actually means. That x to the squared means I have x times x, or x to the first times x to the first. And this x to the third means I have 3 of them. So x times x times x. And what that actually lets me in on is, well, how many do I have? I got 1, 2, 3, 4, 5. So that's going to be x to the 5th. That's all you're doing when you're multiplying exponents. Is you're just going to basically take the exponents and you're going to add them. Now I know I'm going a little ridiculous with all of it here in the next one. But I'm sort of trying to drive in the point home. But yep, we're just going to be adding them. So if I want to look at it drawn out like this, I could, and then just count 1, 2, 3, 4, 5, 6, 7, 8, 9. But isn't it easier to just know that I can add 6 plus 3 and do the same thing? Because that's all I'm doing. But here's the exception. On letter C, what's my exponent going to be on my x's? If I add up, if I'm just looking at the x part here, what's 5 plus 4? Okay, 9. The number in front, okay, the 3 and the 4, I'm still just going to times those. They don't have the exponent on them. So 3 times 4 will give me 12x to the 9th. Because if you have a coefficient, okay, the numbers in front, you just multiply them. And then there's just one thing I'm going to put in before we draw the rule in here. Does anybody know what anything to the 0 power equals? Close. Nope. 1. That's weird, I know. And that's anything. So like if you had 4 to the 0, that would equal 1. If you had x, y, z to the second to the 0, that's 1. Okay? So if you see something to the 0 power, it's going to be 1, which is kind of nice because sometimes that can wipe a lot of stuff out right away. So our rule is when you multiply terms, we're going to add exponents, but we're going to multiply the coefficients. We're going to multiply the numbers that are in front. Okay, if you can keep that straight, this doesn't end up being too bad of a deal. So all you're doing with these examples below, like I said, we're not going to do them all. I just want to do a few so we kind of get the idea here. If we're doing number 9, just add your exponents. So it'd be x to the 8th. I'm done. What if I was doing 12? X to the 15th. I'm just adding up 8 and 7. Now let's throw a little twist in here. What if we're doing number 15? Okay, 9 times 6, my coefficients, I still multiply those, is 54. And 4 plus 3 is 7. Okay. Add the exponents.
What if it's just one number?
Then you just use that number. So like if we were doing 14, for example, okay? If you just see one number, we just use that number. And then we still just add up the exponents. Keep it simple. Now, here comes a twist. Ooh, 17.
16, 11, 49.
Oh. Still multiplying the coefficients. So 8 times 2 is 16. But now that I have different variables, you add the exponents, but they have to have the same variable. So I can add the exponents on the x's. So 3 and 8 is 11. And then I find my y's, and I add their exponents. 4 plus 5 is 9. And I'm set. One more just to be sure. Don't say the answer. Go to 18. Do that for just a moment. And we'll see if we all get the same thing here. For those of you viewing at home, you see the answer, so don't look at the screen until you've done it. Let me grab this. Hopefully we've all got the same thing. 27, because that's 9 times 3, and then 4 plus 5 on my x's would be 9, and 3 plus 6 on my y's would also be 9.
Can you do number 19?
Sure.
What number is the answer?
Okay, so when it's just one number, we're just going to pull that number down. So negative 3 on number 19. Now let's start looking.
X there?
Okay, so x's, I got 9, and then I got 3 over here. Just add up the exponents.
Yeah, we turn
I thought you put an X right by the negative 3.
What's that?
I thought you put an X right by the negative 3.
No, we're just, if there's just one number, that number just kind of sits in front.
Okay.
And then I just look to add my exponents for the rest. Okay, good question. On 20, if I don't see an exponent on my second x, what exponent's there? 1. And now? And then, yep, it's just a multiplication symbol. Instead of seeing the parentheses, I put a dot there. But we're still just going to add up the exponents. So that can be one of the simpler things, but it can also be one of the things that really catches people because they forget about, they don't see the 1, they just write down x to the 5th. So making that x to the 6th, very important thing. I'm glad that one got mentioned. Now, I don't think, let me flip over here just to make sure. I can't think of any other ones here on the back that are going to be a big deal. Just to be sure, though. Let's come down to, ooh, I see a good one, 22 up there at the top. That's what I was looking for. All right, what's my number in front going to be? What's my coefficient when I multiply those together? Negative 30. What's my exponent on my x going to be? 14, because it's 8 plus 6. And what about my y's? Okay. As long as I remember this is a 1 when I don't see 1, 1 plus 6 gets me y to the 7th, and I'm good.
Wait, where are you? I thought it was 56. Because the y doesn't have a...
Yeah, this y over here doesn't have an exponent, so I assume it's a 1. And it's not a bad idea even to write the 1 in, if sometimes that can get to you. And you'll notice back here, sometimes it's parentheses. Sometimes it may be a multiplication dot in the middle. It's still the same idea. Like on 25, I would still add my exponents. I'd still get a to the 5th. Okay, so don't let that throw you off. And otherwise, and again, even if it's a number, okay, 5 squared times 5 to the 4th, they have the same what's called the base, so it can be a number too. Add the exponents. 5 to the 6th. So don't overcomplicate things on this. Sure. Now 29, which are the same? The m's. So we'll add their exponents. 3 and 5 is 8. The n's, there are no other ones.
Oh, okay.
And I just put that on the end. So add the exponents when they have a like base. If there's numbers in front, just multiply them together. Okay. There's only one more thing I'm going to show you today with these. So let me flip you over here. Ignore the page 405 thing at the top. We don't need that. Still in our note packet here. Okay. Power of a power. Well, what happens when I have an exponent and there's another exponent there? What that basically means is, like here in this first one, x to the 4th to the 3rd power means I have 3 of these. I have 3 x to the 4ths. But if I looked at it this way, I know how to do this. It'd be 4 plus 4 plus 4, because I just add the exponents up. It'd be like multiplying. So I look at the end answer, and I go, there might be a pattern here, but let me do one more just to make sure. X to the 3rd to the 5th. Holy cow. So I'd have 5 x to the 3rds. And no, we're not going to have to do this every time. It's just kind of letting us see where this comes from. Well, if I had 5x to the 3rds that I was timesing together, I'd just add all those up. So I'd do 3 plus 3 plus 3 plus 3 plus 3. But, you know, who wants to do all that? No, that'd be x to the 15th if I added up all those 3's. So I start to look at the numbers, and I'm like, 4 and 3 to get to 12, 3 and 5 to get to 15. What do you do to 4 and 3 to get to 12? Multiply. What do I do to 3 and 5 to get to 15? Multiply. So when you go power to power, you multiply the exponents. But here comes the second part to it, though. When I look at this last one, so if I have 3x to the 4th and I have 3 of those, and I want you to physically see this one written out too. Here's the way I want you to look at it. So you've basically here, you have 3 times 3 times 3, and then your x to the 4ths are all together. So here's how this is going to go. 4 times 3 still gets me x to the 12th. Okay, that rule's not changing. But here now, this 3 times 3 times 3, I can either multiply it out that way, which would get me 27, or I could do 3 to the 3rd power. And again, I can even punch that in a calculator with that little caret button if I wanted to do a different exponent. Actually, I will pull that up so we can take a look at that as well. Because understanding some of the button presses can be something that's really helpful. So like here, if I didn't want to do 3 times 3 times 3, this caret button right here, this up arrow it looks like, I can use that, and that can get me to the answer, okay, for the number part.
So you multiply with the number outside.
Correct. So like here, I'd have my 3 to the 3rd power,
Okay.
and I'd just punch it in that way. So that's an easier way of looking at it.
And you do the 4 and the 3 times the,
Okay, so when we actually get into this, let me bump this up a little bit. So like 9, multiply the exponents. X to the 24th, because who wants to write that out 4 times? If you have multiple variables, that exponent outside distributes to both of them on the inside. But I'm still multiplying each one. So x, it's 4 times 5. Y is 3 times 5. And that's going to be my key, just remembering that it goes to each part inside. And even if there's a number, it goes to the number, and it goes to each of my exponents. So here, for instance, I'd have 3 to the 4th power. We'll figure that out in a minute. 2 times 4 is x to the 8th. And 2 times 4 is y to the 8th. But I don't want to leave it this way. I want to actually know what 3 to the 4th power is. So again, and this would work on any calculator. Every calculator has an exponent. No, we want to get down to the final answer because there will be a part where we can simplify it. So like 3 to the 4th, okay, that's 81. So 81, x to the 8th, y to the 8th. And I'm good. Because there will get to be a part where we can simplify these. We'll have multiple of these, so we want to be careful. All right, let me get one more in here just to be sure we're going all right. All right, 12. Notice here, I'm going to put my -5 in parentheses. I'll explain why that's really important in a minute. But just go ahead and put it in that way for now. If I did it with every number, that's probably a good habit. 6 times 4 is 24. 3 times 4 is 12. So I'm still multiplying my exponents. So that part will stay the same. Now here's why I want to put my -5 in parentheses. Watch this. So So let's say, let me put it in parentheses here. So negative 5 to the 4th. Okay, enter. 625. All right. Well, why does that matter? What if I just put negative 5 to the 4th? Ruh-roh. Okay. I'll get a negative, and that negative 625 is not the right answer. That's not what this problem is saying. That's why I'm saying you always have to make sure your number, especially if it's negative, you want to put it in parentheses, because if it's an even exponent, it'll make it go positive. Now, you will get some negatives sometimes. For example, there's two other ones I want to look at here, and luckily they're just to the right of my calculator. Number 18, same deal. Put the number in parentheses, use the exponent, and then just multiply your exponents on the variables. So 2 times 3 is 6. 5 times 3 is 15. And this time when I do my parentheses, because I'm going to do my parentheses every time there's a negative, because I just need to. You're like, well, why is it coming out negative this time? Because it's an odd exponent. Because it's the whole negative times negative is positive and kind of working that through. So you can get some negative answers. Don't think you'll never get any. And then that one's good. Hey, number 17. This one should go quick. Yeah, anything to the 0 power, everything becomes 1. It doesn't mean like the exponent becomes 1 or shit. Like the whole thing is just 1. I know, it's weird.
What if you have,
So every time there's a 0, there's always 1.
Anytime it's something to the 0 power, everything inside becomes 1.
what if you have like, say you have a problem like that, times another problem like that, but they both have 0, would it be 2?
No, because it'd still be 1 times 1, so it'd still be 1. Okay. And the only thing else I'll remind you of, because I tend to forget too, if we have a problem like 23, and this I believe is going to be the last one. Okay, so I'd have 4 to the 5th. What exponent's on my x again when I don't see one? 1. So I have 1 times 5 is 5, and 2 times 5 is 10. And then one last time here, 4 to the 5th. You're like, no, you didn't put it in parentheses. If it's a positive number, I can get away with it. But so 1,024, and then just leave my variable terms alone. Okay. Let me just make sure there's no other weird ones coming. Oh, I see a weird one. Just when I thought it was safe. Like, what the heck is going on here in the back, Hardy? All right, these aren't even bad. When you see the fractions, it's still going to go through to each number. So this ends up being 2 to the 4th power over 3 to the 4th power. And just let the calculator do its thing. So 2 to the 4th is 16. 3 to the 4th is 81. And just to make sure it doesn't get any smaller, if I do a math enter, does it change? Nope. Okay. And I'm good. So all you got to do on that is just basically figure out what each individual part is and keep it as a fraction. So like if we were doing it on 2, it'd be 4 to the 3rd over 5 to the 3rd. And again, I would just do each one by themselves. Get my answer to 4 to the 3rd. Get my answer to 5 to the 3rd and circle it. So, okay, again, this is an example packet. This is a note packet. Keep it out. Don't just put it away, throw it away, do other stuff. This can come in handy sometime if you happen to forget something. So what your job now is going to be, let me shrink this back, is to work on multiply and power practice A. So now, there's two things on this that I want you to pay close attention to. Okay, I'm going to do 1, 3, and 5 with you. And then I'm going to show you some of the weird ones here, because I purposely did some weird ones to get you to think a little bit. So here, I'm just multiplying. So remember, when you're multiplying, I'm going to add the exponents. And when it's a power, which means it's a double exponent, an exponent to an exponent, okay, that's when we're going to multiply them. So in number 1, I'm just multiplying. There's no sets of parentheses or anything like that, because that's typically when I have my powers, when I have parentheses. So I'm just going to times. So negative 4 times 3 is negative 12. What's my exponent on my x going to be? 9, because I'm adding the exponents since I'm multiplying here. And then the y to the third is the only one there. So that one's done. Now this next part's where we got to be careful. On 3, that 0 exponent's only on your variable. So this 6a to the 0, we know that a to the 0 is 1, right? So here, this is actually 6 times 1. Okay, now if we're in parentheses, we'll see one of them in a minute. That'll be a little different. This a to the 0 is 1, so it's negative 3 times 1. It's little details. So 6 times 1, times negative 3 is negative 18. And I know some of you are saying, but you said anything to the 0 is 1. And it is, but it depends on what part of it. I've got to be cautious. So like if I'm doing 5, that y to the 0 becomes 1, which basically means the y part goes away there, but everything else is still there.
For number 7, you're going to add the 4 and the 2, right?
Yes, and the 1 on the m. So like here, negative 2 times negative 1 is positive 2. Add my exponents on my x's, so 5 and 5 is 10. That y to the 0 basically just disappeared. If it becomes 1, multiplying anything by 1 just gets it back. So I just get the y to the 6th then. And that's the one with these that you've really got to be careful. Multiply the numbers in front, add your like exponents. So you're like, okay, so how does that work then on a problem like, let's say, 10? Because now I have parentheses, so now this 5 is going to distribute all the way through here. So, what's the deal there? Well, 3 to the 5th, and then 0 times 5 is 0, and 0 times 5 is also 0 on my y. Well, we just got done saying if it's to the 0 power, basically it disappears because it's just 1. So my x and my y is basically gone. And all I need to know is what 3 to the 5th power is going to be. Well, all right. And I've got my answer. And then I got to go and do something dingy like 13. We're going 0 crazy here. You're like, holy cow, Hardy, 0, 0, 0. Okay, this 0 on the outside, notice that goes to everything on the inside. That one wipes everything. Because with the parentheses being here, that 0 power goes to the v, and the 2, and the v, and the u. And so if they're all to the 0 power, they're all just a bunch of 1s. Okay, but there won't be a lot of these. I want to throw a few in there, though, to kind of give you a heads up on how this works. So like, for instance, what would the answer to number 15 be? One. Because that 0 exponent is going to everything, and anything at all, whether it's a number or a variable, to the 0 power is 1. So if it's outside all the parentheses, we like that. That's fun. But for the rest, there's a little bit of combo work to do. So like for instance, if we kind of keep working through here and we get something like 19. Now here you're like, now what's going on here? Okay, I'm just going to copy the first part because this 3 is going to everything in the parentheses right in front of it. So I've got negative 2 to the third. And when I see the parentheses, I'm going to multiply. It's power to power. So 4 times 3 is 12. 4 times 3 is 12. And now the only thing I've got left to do, negative 2 to the third, if I type that in the calculator, I get negative 8. And I'm going to walk my way through and say, okay, there's my A's. So 3 and 12, because now that it's multiplication, I'm adding, is a to the 15th. The b's squared. Do I have any other b's? Nope. B squared. And here's my c. I don't have any other c's. Same 2 rules. I just got to make sure, because sometimes I'll get both in a problem. Negative 2 to the third power, because that negative 2 gets the exponent, because it's in the parentheses still. And then there's even some at the bottom with multiple choice, so you can kind of see what's happening as you're doing them. We're still going to be doing this tomorrow. We're going to bring in the division, and we're going to just kind of keep playing around with those 3 things for a few days here. So best thing you can do, just try out some, especially some on the front. They're a little bit easier. I got them a little bit trickier as they get to the back. But just keep trying something. We'll have some answers up at the start of class tomorrow. And we'll kind of go back over some of this again and make sure things are going well for you.